Friends, in this video I show you the working of my project, which is based on the design of a compiler. It has three modules. The first module converts C code to assembly code. The second module converts the assembly code to op-level code, and the third module runs the op-level code. So first let's see the working of the first module. This is the first program, C to ASM, and this is our input file, which has a simple C program in it. We are generating the ASM code file, and now let's run the program. This is the generated ASM code. Here in the code, I scan for basic keywords and process the input accordingly to generate the ASM code. Now let's move to the second module, that is ASM to op level. This is the second module, and these are the tables I have used. Symbol table, it stores the addresses for the variables which we use in our program. Memory is for constant variables. Label table, they are used when we mention labels, especially in jump instructions. Instruction table is for mentioning the opcode. Your program, I store the whole code in the file at the beginning. Let us take the file which we have generated earlier and run the program. The output is however stored in a binary file. We use print statements to see the values of these tables. The program is stored at the beginning of the file. These are the instruction table values. These are the opcodes, and these are the addresses. These are the addresses of the variables in the binary file. We haven't used any labels. These are the symbols. This is a constant, and this is its value. Let's run another ASM code, this which uses if else condition. The earlier one was quite simple. Here you can see the labels that have been generated, the symbols and the instruction table, and this is the code. These are the keywords, and we scan for the keywords and process the code accordingly. I've used bit vectors to maintain the memory addresses of variables. Now let's move to the third module, that is op level to the final execution. Here in the third module, we will run the op level code generated earlier. It reads the structures from the binary file generated. Let us run the code which we have seen in the first and second module, that is this one. Here we are reading values into A, B, and then adding it and printing the value, and then later we again perform an addition between A and a constant D and print the result. Let us run and see the output. It reads the value into A first, and then into B. Now the first is the addition of A and B, and the second is the addition of A and constant D. So this is the file. Here we read the values from the instruction table, see the opcode, and perform the execution accordingly. Thank you for it.